Welcome to part 2 of Competency 4 quiz. In this video, we will continue working with algebraic patterns. Number 6, simplify the expression 6x squared plus 5x minus 4 and subtract 7 plus 2x squared plus 3x to the fourth minus x. Okay, first I would clean up the second expression. And remember that we need to distribute -1 to each of the terms inside the parentheses. And also, they are out of order as far as the exponents. So we like to put those things in descending order of exponents. So let's do that. Well, I see -3x to the fourth. So I've done that one. And then I see what would be next. X squared. Okay. So -2x squared. And I did that one. And then negative. And -1 times the -1 would be a positive x. Okay. And then -1 times +7 is -7. Now, I need to add all of that to the first expression because I've already cleaned up my second one. Okay. Well, the highest exponent I have is 2. So obviously, let's set this up. I have a 0 here, and then I have a plus 6x squared, and then a plus 5x minus 4. Okay, then I have it all set up, stacked up correctly, and I will just add like I did in grade school. Okay, so -7 minus 4, that is a -11. Well, if I look at that, I can eliminate A and the B. Okay, now I have C and D left. Well, 1x, here, let me clean that. Let me rewrite all this. Okay, plus 1x. 1 plus 5, that gives me a 6x. Ooh, that looks like it's going to eliminate C, and D is probably my best bet, but let's keep going. So -2 plus 6 is a plus 4x squared. Yes, I agree. And then we have -3x to the 4 plus 0, which just gives us that. Okay, so we verified it's option D. And yeah, unfortunately, we didn't use our calculator, but if the numbers were large, we would, just to verify. And especially this negative right here, if that number would have looked a little dicier or a fraction, -2 plus 6 obviously gives you 4. So if you're getting tired, you can't see things, put it in the calculator. Okay, now the next one, number 7, says simplify the expression. And all of the terms are in parentheses, meaning they're all multiplied. So what do? Well, the first thing we need to do is we're going to multiply every coefficient together. So what is this really going to look like? Okay, this is going to look like 2 times 1, because this is a 1 in front of the a squared, times -4, and then times the 5. And then we're going to look at our a, okay? And a, when we're multiplying the term, a term, remember, when you multiply that base, then the exponents are added together. So we have 1 times 2 times, 1 plus 2 plus 2 plus 1. So 1 plus 2 plus 2 plus 1. Then we have B, and let's see, I have 1 there, and I have none here, but 2 in the last term. Can't really tell what I'm writing there. Okay, and then plus 2. All right. So what does this really look like? Let's see. 2 times 1 times -4 times 5. Well, that's -40. Well, that eliminates everything but A. Well, let's make sure. Let's see. We have -40, and then our A is going to add all these up. 1, 2, 3, 4, 5, 6. That's 6. And then our B is 1, 2, 3. And that verifies option A. All right, now let's look at number 8. Okay, this is a little different. So first, it says, what is the quotient? We're looking for the quotient for the expression, okay, and we have a fraction, okay, with the numerator and denominator being polynomials. Okay, so because we have just a x minus 3, and it's a x to the first power, and then with the ABCD option, I am very suspicious. I don't see a remainder. Doesn't mean they have to tell us about the remainder. They only asked about the quotient, so they could just put the remainder to the wayside. But because of that, let's try something. We'll do this 2 ways. Okay. First, I'm suspicious that we might be able to factor this, the numerator, I mean, and then do some cancellation and quickly see our value or our binomial that we need, okay? All right, so let's see. X minus 3 would have to be in there if we're going to cancel. And then we look at our numerator and I see a 4. Well, this is a 1 here in front of this x. So we'd have to have a 4x. We don't have a choice. Okay, well, then we looked at the leading coefficient. Now let's look at the ending exponent. I mean constant, sorry, the ending constant. Well, -3 times +7 equals -21. Now we go over to our ABCD options and we see B. But let's follow through. Let's make sure we would have to take the outer multiplied together and the inner multiplied together and add those two. Let's see what happens. 1 plus 7, I mean, I'm sorry, 7 times x is 7x. And then -3 times 4x is -12x, okay? Well, 7 minus 12 is -5. And we have that in the middle. We have a -5x. Okay, so now what? Well, can we cancel? Well, yes, we set it up suspicious that we could cancel. So if we cancel, then we know we have 4, here, let me change this. We have 4x plus 7 would be the quotient that we're looking for, right? But let's do this the longhand way, long division. X minus the 3 all underneath we would need 4x squared minus 5x minus 21. Okay, if you watch the other videos with me, remember, you need to figure out what would give you exactly 4x squared. Well, that would be 4x. Well, that's what we have for our B. Well, that's also D, but let's keep going. Well, that would be 4x squared minus 12x, okay? So put that in parentheses, put a subtraction in front of it, bring down the 21. Now let's subtract. Well, 4x squared minus 4x squared, oops, that's supposed to be squared, is 0. And then -5 minus a -12. Let's put that in the calculator. -5 minus a -12 equals 7. Okay, so we have a 7x. Now, let's see if we can eliminate that. Well, that would just be plus 7. Okay, 7 times x is 7x, and 7 times -3 is -21. Now remember, you have to put those in parentheses and subtract, and they both give you 0. So yes, we have verified that option B is what we needed. Okay, let's try number 9. Use the coordinate grid below to answer the following questions. Number 9. The graph of a line not shown with equation y equals mx plus b, where m is a positive constant and b is a negative constant, has points in which of the 4 quadrants above. Okay, so let's write that out. Y equals, let's see, our m needs to be positive. So we can just say that's a positive 1x, but our b must be negative, -1. Okay, so let's think this out. If we're at -1 here as my y-intercept, and my line is positive, meaning that's a positive slope, that means my line must go up like this. Well, which quadrant does my line not go through? Well, that's Q2. Okay, so anything with quadrant 2 in it must be marked out. So that's A and B and D. So looks like option C has been verified. And you can put that in the calculator and verify that you do not have any values that are a -x and a positive y. Okay, so let's push table. Let's clear that out. And let's say x minus 1. Okay, that looks good. Okay, let's start at 0. We're counting by whole numbers, so steps 1. And there we go. Okay, I do not see a case. I'm up here in the negatives. I have none that have a positive y. Okay, so that is verified. All right, let's look at number 10. Which of the following represents a function? Remember, functions cannot have repeating x values. So let's see here. 3, 3. That is not a function. We are looking for something that is a function. Well, x squared minus y squared equals 2. That isn't a circle, but it's an ellipse. So, no, I'm not going to buy that. That's definitely not. It's close enough to a circle. So, obviously, it won't work. And now, see, that is a circle. You got to be kidding me. Well, that's not a function. All we have left is D. Well, we could see that if we put this in y-intercept form, what do we actually have? Okay, here, we have y equals x plus 3. Okay, and as we discussed in the prior video, can't remember which one it was, all linear equations are functions. It's a straight line that passes the vertical line test. So it is what it is. All right. So let's try number 11. Number 11. Which of the following graphs does not represent a function? Okay, does not represent a function. Okay, that means it will not pass the vertical line test. And remember the rules of, of the vertical line test. We cannot have the line passing through as we draw it straight down. We can't touch 2 points, okay? So let's look at option A. If I go straight down, do we go through 2 points? Well, none of these do. If I could draw straight, that'd be great. None of them do. Why not? Well, if I could draw, yeah. Well, I'll get rid of this one and kind of point it out to you. This is an open circle, meaning we cannot, quote unquote, count that it goes to 2. It does not equal 2. It equals everything up to 2. So because of that, each of these lines are only passing through 1 point, therefore they are a function. And this particular graph has a name. This is the step function. The name itself calls it a function. So that's not what we're looking for. Okay, let's look at this. B, when we draw our vertical line, we are going through both solid points. That is not a function. So I'm going to circle that. I'm going to say that counts. So then let's look at C. When we draw our vertical line, everything passes. But then we have a question on the y-axis. But like I said above in A, this open point or open circle says you cannot count this point. So therefore, it only goes through this point. So that makes it a function. So mark that one out. Now, obviously, D, that's a function. It's the absolute value of x. And it does, as you draw your vertical line, it only passes through once. Therefore, it is a function, and we'll mark that out. Okay, this is the last question in this video. Thank you guys for watching and sharing and liking our channel. I wish you all the best. Happy testing.